Here's homework help for number 85 and 6.3b. A tether ball weighing 1 pound is pulled outward from the pole by a horizontal force U until the rope makes a 45-degree angle with the pole. Determine the resulting tension in pounds in the rope and the magnitude of U. So let's write down some information we know from our figure here. So U is the ball being pulled outward, and so let's just make the center as our origin here. So therefore we have U is being pulled out at 0 degrees. Then we have this tension here of the rope. This is 45 degrees here, so we can say that this is 135 degrees here. And then with the weight here, that's 1 pound, so I'm going to call that W, and it's being pulled straight down, so that is theta is 270 degrees. Now the other thing we know about this W is that we can say the magnitude of W, we do know that, because that is 1 pound. So let's start with writing 3 equations. We have U, the vector U is the magnitude of U times cosine of that 0 degrees, I, plus magnitude of U, sine of 0 degrees, J. Let's simplify our equation a little bit and evaluate cosine of 0 and sine of 0. So we have the magnitude of U, cosine of 0 is 1, and then we have I, plus the magnitude of U, sine of 0 is 0j. So we can simplify this as vector U is the magnitude of U, I, plus 0j. Next, let's write an equation for W. So we're going to use W for the ball, for the weight of the ball. W is the magnitude of W, and then this is times cosine of 270 degrees, I, plus the magnitude of W, sine of 270 degrees, J. Now the magnitude of W we know is 1. And then cosine of 270 degrees is 0, and then I. And then the magnitude of W again is 1. Sine of 270 is -1, and then J. So we can write the vector W is 0I minus J. Now let's talk about the tension of the rope. So I'm going to call it vector T. T is the magnitude of T times cosine of 135 degrees, I, plus the magnitude of T, sine of 135 degrees, J. So we're going to write 2 equations, one horizontal and one vertical. Before that, I want to be able to talk about these vectors, and we can say that if we add these vectors, so U plus W plus T, so vector U plus W plus T, that is going to equal 0. So we'll just say that all of that tension is keeping the ball in place, so it makes everything equal 0. So let's write an equation containing all of the horizontal components. So horizontal. And so all of that is going to be that the values that have our I here, or the cosine. So for the horizontal, we have the magnitude of U. I'm not going to include the I. So magnitude of U. Then I have plus 0 for W. And then here I have plus the magnitude of T, cosine of 135 degrees, and that's all going to equal 0. So we'll evaluate that 135 in a little bit. Next, let's write our vertical equation. So starting with the U, we have 0, and then for the W, -1, and for tension T, we have the magnitude of T times sine of 135 degrees, and again, that equals 0. Now here in this vertical equation, we really just have one variable, so let's solve for that. Let's add 1 to both sides. So now we have the magnitude of t, and then we have sine of 135 degrees. So sine of 135 degrees is positive 1 over root 2, or you can think about that as root 2 over 2, either one. And so 1 over root 2 equals 1. Then to isolate the t, we're going to multiply by square root of 2 to both sides. So now we see that t equals, the magnitude of t equals the square root of 2. So now we can plug in this t into our horizontal equation in order to get u. So let's plug it in. We have the magnitude of u, and then plus, we know t is square root of 2. Cosine of 135, so that is going to be, cosine of 135 is negative square root of 2 over 2. So I'm going to go ahead and use square root of negative root 2 over 2, because I'm going to multiply, and then that's going to equal 0. So then let's multiply. We have the magnitude of u plus, we have square root of 2 times negative root 2. So that is going to be negative 2 over 2 equals 0. So magnitude of u minus 1 equals 0, or the magnitude of u equals 1, which is what we were looking for in the beginning. So the magnitude is 1